Hi there students, so now we're looking at another question 3 from the worksheet. So before we decide whether this is going to be chai or whether it's going to be a t-test for paired samples, let's just read it. A study of a group of bikers sets out to prove if the full moon has an influence on disruptive behavior. 6 bikers from a particular club were included in the test, and 2 nights were selected, namely a night without a full moon and then a night with a full moon. On each of the test nights, the number of disruptive acts for each biker was responsible for was recorded, and the results are displayed in the following table. Now, because I've extended the table from what I gave you on the worksheet, one can easily make the assumption that this is going to be the t-test for paired samples. But as an explanation as to why, I'll remind you that in class we said that samples that are identical in every aspect except one. So it could either be a sample, the exact same sample, and there's treatment that is carried out on the sample before and after, or it could be 2 samples that are identical in each and every way, and the example I used in class was twins. And for this type of sample, these type of samples, we can see that they are paired in a particular way. Now, in this example, it is the same individuals, and the treatment, or it's not the treatment, but we'll refer to it as the treatment, is the full moon, and on another night, there was no full moon. But as explained, in every other area, they are identical. So when we look at the individuals that's been tested, we'll see that there is a name Gary, Zaki, Bassi, Lala, Ricky and Ati, and those would be our samples. This question continues to say at 95% confidence level, conduct a hypothesis test to test this claim. So if we have a look at the information that we're given, this particular question does not specifically ask us, is there more disruptive behavior after the full moon, or is there less disruptive behavior after the full moon? We basically, for this particular question, we basically just want to establish if there is a difference or not. So the null hypothesis in this particular question would be the mean difference is equal to 0, and the alternate hypothesis would therefore be the mean difference is not equal to 0. What is the mean difference that we're speaking about? The mean difference we're referring to in this case is the behavior or the number of incidents. So what we know for a paired t-test, we need to draft this table. So because I already extended this table, that gave you a clue that this is the type of test that we're going to do. So when we do this table, let's see what we are required to do. For Gary, we would list obviously the before, and then we list the after. And for Gary, the mean difference would be 0. For Zaki, the mean difference is battling with this. Okay, for Zaki, the mean difference would be -6. And now it's important, it's very critically important that you keep a track of all of the incidents A, because I'm going to write over this no full moon. That would be incidence A. In fact, let me make that pen a bit thicker. This would be situation A. And this would be situation or factor. Let's call it factors. Factors A and factors B. And what you have to pay careful attention to and ensure that this takes place is that for each individual or sample, you have to make sure that you use it in the correct order. So first factor A or first factor B, you can decide, as long as you keep factor A's together and factor B's together. So then for Bassie, it would be 4 minus 3, and that would be 1. For Lala, it would be 5 minus 7, and that would be minus 2. For Ricky, it would be 0. For Ati, it would be 1. And so what we now do is we calculate the mean difference. And the difference, the sum of the differences would be, well, yeah, you'd add all this up. So you can use your calculator in stats mode. So this would be minus 5, minus 7, minus 6, and you divide. What I did is I added all of that up and I came up with a total of minus 6, and I divided by the 6 individuals, so my mean difference would be minus 1. I then go on and I do the standard deviation calculation, and the standard deviation calculation entails me taking the difference, so that over there, for each of them, I'll do the same for each of them, and I subtract the mean difference. Now using BODMAS, I'm going to have an answer of 1 there. So I do the very same for each of them. So for Zacchaeus, minus 6, minus 1, and I have an answer of minus 5. For Bassie, it is 1 minus 1. And that sign, please note, that sign is important. It will influence your calculation if you don't have that sign there. So for Bassie, the answer is 2. For Lala, we'd go minus 1. And the answer is minus 1. For Ricky, the answer is 1. And then finally for Ati, the answer would be 2. So once I've done that, I then go on to do the variance calculation. Now we remember that the relationship between standard deviation and variance is standard deviation squared. So variance is standard deviation squared. And that is something that as stat students we know off by heart. So when we have a look at each of these individual values, 1 squared is obviously 1. Minus 5 squared is 25. 2 squared is 4. Minus 1 squared is 1. 1 squared is 1. And then the answer to 2 squared is 4. And now what we do is we take the total. So the total of all of these values is 36. And this is important for our ST. We are going to use, so the reason why we did this whole table is there are 2 things from this table that we need for our test statistic, and that is the mean difference as well as the SD. Now SD, this is not, 36 is not SD. We first have to calculate SD, and so we'll calculate SD. We'll calculate SD using the following formula, and this would be in your notes. This is that variance calculation. Variance calc. It's actually the square root of the variance calculation over n minus 1. So the square root of that variance calculation, we had a value of 36 there. If we remind ourselves, our n was 6 because there are 6 individuals. So this would be 5. That would be 5. That's my ST. And the answer for that would be 7.2 ST, and the answer is 2.6833. And this value I'm going to use in my test statistic. My test statistic for the TP test. Oh, my handwriting is leaving much to be desired, but I think that you guys can follow what I'm writing. Is the mean difference. So this is the difference, the mean difference, and that I calculated is minus 1. In fact, let me just erase this line and make it a bit shorter so that I can fit it all in on the same page. Over SD divided by the square root of n. So I know that my mean difference, remind myself, that is my mean difference, which is minus 1. So I'll fill that in here. Minus 1 divided by that SD, which is 2.6833, divided by the square root of 6, and the square root of 6 is 2.4495. When I do this calculation, the answer to my test stat that I get, in fact, let me actually first just do minus 1 divided by the answer of that is 1.0954954, and the final answer is minus 0.9129. So this would be my test stat. Okay. Now this is a t-test, which means that I can read the value of my t-table for my critical values. At 95% confidence level, we remind ourselves that our alpha is 95%. However, we've got a equal to sign in our null hypothesis, which means we need to divide that alpha. Now, 95% confidence level, we know, is 0.05 level of significance. And with an equal to sign, we need to divide that by 2. So our alpha that we have to use is 0.025. So let's have a look at our t-table, and our degrees of freedom that we're going to follow is n minus 1. So at 0.025, n minus 1, it's 5. Our critical values would be 2.5706. And the t distribution is symmetrical, so it would be plus 2.5706 and minus 2.506. So let's just write that down. I've only got 30 seconds left in which to finish this video, but I'll quickly draw that. That would be 2.5706 plus and minus 2.5706. My test stat is 0.9129, which means it falls in the acceptance or non rejection area.